All right, now all my stuff is loaded. Good morning, everyone. Thanks for having us here. I will go ahead and jump in. So we presented a 50% chance of a good session, understanding probabilistic information for weather decisions previously at IAEM. Now, some of this content was definitely geared towards just educating EMs on the very basic level. So I have some slides that I've skipped in here, but we're going to go ahead and kick off. Think about this to yourself. If it takes 5 machines 5 minutes to make 5 widgets, how long would it take 100 machines to make 100 widgets? Now, if you're anything like me, the first number that popped into your mind was 100. And then when you actually think through the little riddle a little bit further, you realize that with the same rate of production, it still only takes 5 minutes for these 100 machines to make 100 widgets. So what was going on here? This is 2 different cognitive processes. Here are system 1 brain and our system 2 brain when we come to decision making. Our system 1 is unconscious, it's fast, it's automatic, and it's for those everyday decisions. It's experience-based, but it's often error-prone. This is how you basically drive home and not even remember how you got home, but you're kind of just went into that auto mode there. System 2 is conscious, it's slower, and it's controlled. It's better for those complex decisions that have and consequential decision making. It's more reliable, but it can be lazy as well when your system 2 is specifically untrained a little bit. So let's take a look at another example here. Common injuries children suffer. You see some percentages here at the bottom and spinal at 5.2%. That is kind of a high percentage, right? I mean, I know a lot of kids, I've got a big family, and I have never heard of a kid getting a spinal injury, right? It's kind of rare, you would think. But with that header, common injuries children suffer, and then that direct line to that 5.2%, our system 1 is operating here. And then you're getting a little suspicious, right? I'm starting to think about all the kids I know, and that's my system 2 engaging, right? I'm trying to raise some flags about how I'm processing that information. And realizing that that subheader here says top traumatic orthopedic injuries for which children are hospitalized. So this is where how the presentation of information can be somewhat misleading, and our system 1 can be trained to almost make the incorrect decision even with the information in front of us. So if you're curious, the actual rate of a child with spinal injury per year is that small. So definitely a misleading way of presenting that information. So what am I rambling on about? What is this all from? This system 2 and system 1 cognitive theory is from the book called Thinking Fast and Slow by Daniel Kahneman. This is a widely accepted psychological theory that describes these 2 distinct cognitive processes that occur when we're making judgments and decisions here. So why we want to train, right? So our system 2, that's more slow, it is smarter, it's controlled. We want to convert that into our system 1 thinking so that we're more quickly coming to the correct decisions here. So in weather communication, this is important because our system 1 is leading us into decision-making pitfalls when we're encountering probabilistic weather data. And I say we, as in, yes, meteorologists, emergency managers, the public alike, we all fall victim to the same pitfalls here, even though we have, a more in-depth understanding of these probabilities. So this is one of the slides I decided not to skip because I like this analogy, but probabilities are a really useful forecast tool. This is something that I have used to describe this to emergency managers that I stole from my previous Sue, Ted Ryan. But if you think about the game of blackjack, in the 20th century here, when we discovered meteorology as a science, that's kind of similar to just learning the basic rules of the game, right? So blackjack, it's not the most complicated game, but you still got to take a little bit of time, get used to it, get used to your strategy. And then in the last 70 years or so, we've developed numerical modeling. So that's basically learning the best ways to play a hand to win. We've got some strategy here, but we're not perfect. And then probabilistic forecasting, still not perfect, but it's about as good as you can get if you think about it in terms of blackjack, counting cards to know the odds for every move here. So in the last 10 years or so, we have really advanced our probabilistic forecasting like this. And this is a very useful tool. So of course, knowing all the probabilities of what to do with a blackjack hand doesn't allow you to predict the card that's played next. But often over time, you will win more with more hands that you're playing here. So why shouldn't we do this with weather? So that's just something that I like to put in perspective a little bit. I know there's the goalposts and things like that that have been referenced as well with EMs. And of course, acknowledging the disadvantages of probabilistic forecasting. It's more complex to communicate. It does require some training of our end users, and probabilities can't be right or wrong in any single event, which can be uncomfortable to sit with. We're very binary in our decision making. We want a yes and we want a no. So I'm going to dive into some of these pitfalls before I hand it off to Greg here a little bit later. So our pitfall number one, this graphic is just an example graphic. So you can see some of this setup and how we commonly display most likely scenarios here and less likely scenarios. So I know that low track graphics are also similarly done, but on our graphic here, we've got a most likely scenario with a 70% chance of occurring. We've got green, heavy rain and flooding over south central Florida. And in our less likely scenario, we have a 30% chance of occurring with the heaviest rain really near the Florida panhandle. So when our users are looking at this graphic, and NWS meteorologists as well, we've actually polled NWS meteorologists, and they also fell into the exact same pitfall, over half of them. This pitfall here is that this is the scenario-based graphic here, right? So these percentages shown on the graphic are not precipitation chances. We have presented shades of green, percents, and thunderstorm icons for years, and it has meant that that is your chance of rain, right? That's your pop. These are actually your chance of your scenario occurring. So looking at cluster analysis and depicting how likely it is for even that scenario overall, right? Not just our actual rain chances. So you're usually showing this 5 to 7 days out when our confidence is lower, and it is advantageous because it allows us to show that lower probability, but worst case potential, while visually emphasizing that most likely outcome. And so this is a great way to message our overall outcomes in the extended, but it's harmful when we are presenting it in this way because it can be misled. And so using shades of green, things like that with our percent signs is very dangerous when we're talking about anything that's not a pop that can be interpreted as a pop. All right, so scenario-based pitfall there. Moving on to exceedance here. So in Austin, you have in that highest bin, that highest colored bin from 90 to 100 there, that is your chance of receiving at least 3 inches of rain. So how much rainfall do you expect to receive in Austin? You can think about this to yourself. You can throw a comment in if you'd like. But I'll go ahead and say that 40% of the meteorologists internally that were surveyed here actually underestimated the totals when looking at a similar graphic here. So and we've asked a lot of our partners here, what do they think their rainfall that they are going to receive is in this type of scenario, and more often than not, the answer is 3 inches of rain. What is going on here? So our users are falling victim to anchoring. This is a cognitive bias that describes the common human tendency to rely too heavily on that first piece of information offered, the anchor, when making our decisions. This occurs when people consider a particular value for an unknown quantity before estimating that quantity. So this is problematic with our exceedance-based information here. When we are showing the chance of conditions meeting or surpassing a certain threshold, but we don't actually have a way to really quantify the risk very well. And so that helps quantify our risk, but when we don't actually have the most likely forecast information up front and center, this is misleading. Our high exceedance probabilities actually can mean, right, that the actual conditions could far exceed the threshold that is shown. So they need to be prepared for the potential of more significant amounts. we're not getting that point across when we're messaging and emphasizing the exceedance information visually over our most likely forecast information. This is because our system 1 here is being anchored just by the mere suggestion of that threshold. So you have a 90% chance of 1 inch of snow. Your system 1 is going to try its best to construct a world where that 1 inch is the correct number. Then if you think, well, I was probably going to get more than 1 inches, but you don't know how much, you are often anchoring and adjusting here. So you're still anchoring yourself to that system or to that threshold right there, that 1 inch. And then your system 2 is trying to adjust. So I'm probably going to get 2 or 3 inches. Our system 2 often has an insufficient adjustment because it can be lazy or depleted when making multiple decisions here. And so this can be problematic as well. And so even when our system 2 is engaging, we are still making errors when we're estimating these values. And so the bottom line here, don't provide exceedance information without your most likely forecast. Emphasize your most likely forecast up front and center on the graphic if possible. Be intentional with the threshold that you show on a graphic, especially when we're dealing with limited real estate. We need to kind of triage, right? So what's the most important threshold for the bulk of your partners, the bulk of the people that are going to be seeing this graphic? But then if you have time to give personal DSS, right, to one of your jurisdictions, you can provide multiple thresholds along with that most likely information, because those multiple thresholds are actually shown to reduce the stickiness, that anchoring on any one specific threshold. So that can be beneficial as well. All right, let's see. So we've got some range forecasts here. This one is a little bit difficult. I don't think that anyone is going to interpret Austin having a high of 98 and a low of 84, most likely looking at this graphic, although not impossible. But this is just an example here. I'm going to cover this fairly quickly for our range forecasts. So what's happening here, our range forecasts are only for a snapshot of uncertainty, right? So one time and one location. It is not a high and low temperature as it often looks like at first glance. So you see for DFW, we've got what could potentially be interpreted as a high temperature of 29 degrees and a low of 7 degrees, not too far off, more forecast this week, pretty cold. But what's going on here is they're interpreting it that way because they do not even realize that uncertainty is being expressed by the visualization. So they're automatically going to interpret it as a deterministic quantity. This is deterministic construal error. There has been multiple studies to show the rates of misinterpretation with range forecasts here are similar. No matter which way the range is turned or changed to try and make it look different, and try to even add in the diurnal ranges as well, and make it more obvious. It still shows about 40% of the public actually misinterpret this. So what's going on here is this likely is occurring on an unconscious level before one is even aware that there's an alternative interpretation. So this is our system 1 thinking. So our system 1 brain sees a temperature above one on the other, and are so used, especially with our broadcast media, presenting information this way, high and low temperatures, that we're not actually presenting the probabilistic information here that we think we are. All right, so I'm going to wrap that up and pass it along to Greg. Let's see. Greg, were you going to share your screen?
Yes. Yep, I will. Yep.
Perfect.
Okay. I'm frozen, I see on my screen, which is amazing. I love being frozen. It's so cold here in Boulder that I'm frozen just everywhere. All right, so as we dive into the next little part before we get to Kevin's fun activity, I'm still frozen. My goodness, I don't know what's going on here. Question for you all in the audience. Wow. What do you think is the more confident forecast scenario? Or scenario A or scenario B? And you can put it into the chat, or you can just completely ignore me and I'll just go ahead and answer the question for you. I mean, because again, it's all personal preference, right, in a sense. Like, we're trying to understand what folks really think when it comes to this, scenario B. But honestly, a lot of people will answer this question when we did these talks, at IEM or just with other local EM groups, or even within in the house here in Boulder. there's a varying array. It's like 50-50 almost, because they both are fairly confident forecasts. Exactly, right? Same confidence. Thank you, Mr. Howard. Good to see you, buddy. But it just comes down to the impacts, right? So the whole point we want to discuss going forward is, confidence is great, but there are limitations to the confidence and the pitfalls with the confidence. All right. So I'm going to kind of just highlight all these on the screen right now. When we speak of the confidence, we have to have the scientific evidence to kind of back it up, whether it's more of just pattern recognition leading to the high confidence, whether it's all the ensembles, numerous models, all the cams, whatever we're looking at the particular day, all kind of coming together to paint the picture that you see conceptually in your brain with whatever weather pattern it is, or whatever impact there could be going forward with that event. So it's going to be highly variable and dependent on multiple factors, both the seen and unseen. And what we mean by that is there a correct definition for the confidence pitfall? And the answer, much like the previous example between scenario A and scenario B, is no, there are multiple. So statistical confidence, again, adding a percentage to how confident you are to maybe what the ensemble is showing, 90% chance of exceeding, again, in this case, 1 inch of rain, so high confidence that way. The event confidence that we're just saying in general, there is a high likelihood or high confidence we're going to receive impacts from this heavy rain today, but what does that really look like? What can partners use from that information to put their plans in action or whatever it might be? And then the experience-based confidence, more so that the guttural feeling that you have, the gut feeling saying like, I've seen this before. We got east flow across, eastern Colorado. We got dew points in the 70s, which for us here in Colorado, 70-degree dew points is tremendous moisture. For those along the Gulf Coast and out in the Ohio Valley, absolutely not. But here, that's like 86-degree dew points for those who are at sea level. So 70 is like our trigger. It's like, oh, that's gonna be a bad day. With east flow coming into the mountains, the flat irons, boom, big thunderstorms happening, and possibly lead to severe weather and flash flooding. So again, one of those kind of situations. Now, we've all used SPC, going forward. It's one of our things to do in the spring and summer months. Inherently, SPC outlooks are probabilistic, and we show this to folks. EM's primarily saying like, well, listen here. So here's the overall scope. What we're saying is that there's a chance or a likelihood at X percentage of seeing severe weather impacts, whether that's going to be the hail, the winds, tornadoes, so on and so forth. And really, the smaller bins, the smaller box you get, they're done for a reason, because then you're adding higher confidence, higher certainty into those areas, but also means impacts could be even worse in terms of the coverage of storms or the severity of the storms. But regardless speaking, we're looking at the probabilities of having severe weather anywhere within that outlined area, at a certain percentage, which leading to our confidence going forward for that particular day, or whichever time frame we're looking at here. So we always need to add that context to it. And one thing that I have heard from all of our partners is, I think a lot of us do it here in the region, really across the country, is the numeric value, 1 through 5 on the scale versus using the words marginal, slight, enhanced, moderate, and high. That the partners really gravitate towards using the numeric number. So 1 out of 5, basically, or 2 out of 5. Kind of, they like that more than actually the words themselves, because to them that means a lot more in their operations when using the actual numeric value for what the outlook parameter or outlook area is going to be. So just more so as an anecdote that I've heard from our partners here. So what? Okay, this is something that Madi did last time. So Madi, please, if I butcher this, please step on my toes and hop on in and say you're an idiot, Greg. You know what you're talking about, because this is going to be fun. Primarily speaking, we want to communicate with credibility, right? So what you see is what you get, but we have to communicate properly, basically saying plain language to our partners. Nothing scientific, no jargon, kind of like our key messages across the region, right? Simplistic, succinct, plain language stuff to them, because they need to use both System 1 and System 2 processing to understand what the message actually is saying. So we want them to use their System 1 to make decisions quickly, but also, don't get too quick to the gun, like really kind of dive into what the System 2 is showing you. And that is where them encouraging your partners to give you calls, to put a message out there in the BOS chat 2.0 or Slack, because others might have the same question, and want to get information in terms of how am I best understanding this graphic you're putting out there when it comes to probabilities of the event unfolding. So Maddie, I do apologize with this information here. So I think we can set this out to everybody going forward too, and you can probably read these a lot quicker than I can discuss them. So Maddie hopped on. So Maddie's going to save me. Yes, Maddie.
No, all good. So essentially, just recapping. This is essentially just recapping kind of the things that we went through already. So your system one is going to make some snap binary judgments. We can use that to our advantage, but we have to be cautious when it's also a disadvantage to us. And so when we can use it to our advantage, right, we want people to be able to make quick, reliable decisions, especially when they're dealing with things, variables that we can't see. But then when we do need to dive deeper into something that's more complex, right, some probabilistic information that we want to ensure that they're taking the time to look at it properly, that's when you want to kind of leverage that system two and try to engage that system two a little bit more. And so going into the deeper details that you can, and using frames of reference, things like that. And so, yeah, this anchoring is just essentially a recap of what I presented on as well. But the what you see is all there is type content. Yeah, that's all in that book. It's a fantastic book. I'd recommend reading it. It's a little lengthy, a little heavy, but it's a good book. But the what you see is all there is exactly what it sounds like as well, is everything that's on a graphic is what they're using to make judgments. And we are radically indifferent to the quality and the quantity of evidence that's presented to us, especially when we're depleted from having to make multiple decisions like our partners often are. So just be cognizant of what's going on your graphic. Try to emphasize your most likely up front and center no matter what. And try to avoid things that are overly complex. Leverage that plain language, those sorts of things.
Thank you very much. And I'm currently reading the book as well too, which is helpful. I'm actually more of an audiobook fan, because I don't have time to sit there and read with 3 kids and just everything else going on in life. So definitely good to have some kind of source for that information. It's on Audible, so that's why I'm reading it. I'm listening to it mine right now. So I mentioned this kind of a little bit before too, but if the partners have questions, obviously we know we are 100% customer service oriented, and we want to encourage folks when questions arise based off of our graphics or based off of our AFDs or information in general, or watch warning products, what it would be, that they have enough time to reach out to us and ask us questions, that they value our opinions and stuff on board. So just make yourself available as much as possible, especially when we're diving heavily into the probabilistic realm when it comes to messaging wise going forward. So just one way that out there. I think we're all really, really good at that as well too. And then for the partners too, there's a little video series. I think each video is about 3 or 4 minutes long. About 4 or 5 of them are kind of discussing how uncertainty and the confidence probabilistic realm are being relayed to them via our products. So all right, I think I butchered that enough. So I'm gonna turn it over to Kevin now, and we're gonna play a little game.
All righty. Thank you, sir.
I will go ahead and stop sharing, Kevin. You can take it over.
All right. Fabulous. You guys all with us still? Could we get some thumbs up? You still awake? Thumbs up. All right. Fabulous. Perfect. Well, congratulations. You all are all snowplow drivers today. What a day for that in Missouri. Hope you can see behind me. No, Jenny, we're good. I think we're good. Thank you, though. Yeah, what a day here in Missouri. Like I said, if you were on the call a little bit earlier, we got several inches of snow here locally with a foot of snow down south. So what a day, and how relevant this is. So what we're going to do, and the way we did this, I'll kind of start with how we did this with the emergency managers, just to kind of paint the picture for you all. You might have heard of Dr. Jocelyn. She's a social scientist research, and she's done work in this area. And actually, this game was kind of inspired by some of her work. But what we did with the emergency managers, you can think, big conference room, we split half the room into a deterministic group. So they get deterministic information, and then we split the other half into a probabilistic group. So it's a little hard to do that virtually, but we'll work through that here in a second. But basically what you're going to do is you're going to decide which chemical to use based on your temperature forecast. And if you were in the room, you would have got a prize, but you're not in the room, so you don't get a prize. I'm sorry. But here are your choices. So we have salt brine and beet juice. We actually worked with MoDOT, Missouri Department of Transportation, on some of these values, at least the ratios of the values. Obviously, it takes more than $500 to salt Missouri, but the ratio of the values, just to kind of make the game a little more realistic. But here are your choices. So you have salt brine. This is the cheapest option. It's a $500 per application. Let me hide this here. The problem with it is it only works at temperatures greater than 25 degrees. So 26 and greater, salt brine will work. Beet juice is more expensive, about $8,000 per application, so significantly more expensive. But the good news about that is it works at all temperatures. So it kind of covers you at that 25 degree or below threshold. So here's what the game is. So you're going to start with $100,000. I gave the emergency managers 12 forecasts. I don't think we're going to go that far with you all, just because you'll understand the game here soon. And then the group with the most money at the end wins, right? So as meteorologists, we're thinking and we're hoping that the probabilistic group will win. And I will say every time that I've done this, which is, gosh, I don't know, 6 or 7 times now with partners, the probabilistic group has always won. So that's good. I also think what the intent of this game is to really have them understand that maybe they don't like probabilistic, maybe they feel like they don't understand it, but they actually make better decisions when they use it. And so that's really the intent of this, is to kind of introduce probabilistic to them. And Maddie and Greg did a really good job of that. But then kind of show them, like, no, you really will make better decisions with this kind of information. And it might even help some of your staff as well. I know we have some naysayers still in the Weather Service of where we're going with probabilistic. So it might be kind of fun to play with your staff too, if you have some of those in your office. So yeah, so I will say so you get the $100,000, the group with the most money wins. Here at the bottom is kind of important. So if you use that salt brine, that cheaper option, but the temperature ends up falling below that 25 degree threshold, you're going to be assessed a labor charge of $5,000. So you'll have to pay the $500 for the initial application, the labor charge $5,000, and then the $8,000 for the beet juice that you have to put on. So that's a significant hit to your budget, should you try to be cheap and not do the beet juice. All right, so here's just a practice, and we'll if you want to just throw your answer in the chat, we'll do it that way. So our forecast calls for a low temperature of 30 degrees. You're getting a deterministic forecast. What chemical are you using? You got a little cheat sheet up here at the top. So 30 degrees, what chemical are you going to use? Throw it in chat if you don't mind. Come on, I know you're awake. I saw a thumbs up. There we go. Salt, salt, salt. Fabulous. That's what I needed. Perfect. You use salt brine. The observed temperature low was 31. You made the right choice. Great work. Great work. Here's what the probabilistic forecast will give you. So we call for a 90% chance of the low being more than 25 degrees. What chemical would you use? We'll just go with salt. That's a pretty easy one. Same thing. You use salt, $500 to apply it, and the low was 31 degrees. You made the right choice. All right, another practice here. So now the low is, the deterministic low is 26 degrees. What chemical are you using? 26 degrees. Beet juice, beet juice. Oh, some risk-averse people, huh? Boo. I would have gone salt. I'm a gambler. Throw salt on it. See what happens. All right, the low ended up being 24 degrees. So let's say you chose salt. The temperature got too cold, so now you had to spend the $8,000 on the beet juice and the $5,000 on the additional labor. So that one, if you chose salt, you would have lost quite a bit of money there for the additional charges that you would have had to incur. But the probabilistic forecast, a 70% chance of the low temperature being above 25 degrees. All right, so this was one of those cases where 70% chance above, probably would have salted, right? Take that 70% chance, take your 30% risk. But in this case, that was still the same forecast. So the deterministic actually ended up being 24, or the observed low ended up being 24 degrees. So we had to use the additional labor costs and the beet juice fee for even the probabilistic team. Now, if you use beet juice for probabilistic and were risk averse using that 30%, good for you. You would have saved yourself a lot of money. So that's a game, like I said, pretty straightforward, but it's kind of fun to throw some numbers at it. So the way we kind of did this with the last virtual group is we had 2 volunteers. So if I can get 2 people to raise their hand. One of you will be deterministic, and one of you will be probabilistic, and you'll have to answer for your team, or you'll represent your team, which will just be yourself in the game. So anybody wanna be the deterministic guinea pig for me? Raise your hand. If not, I will call on somebody. I'm not above that. Going once. All right, Jake. I knew Jake would volunteer. All right, so Jake's going to be the deterministic team. Anybody want to be the probabilistic? Come on, that's the easier one, right? Chances of winning are higher if you're probabilistic. I'm just saying. All right, I might. All right, Matt and Jake, bail me out. Appreciate it, guys. All right, so Jake's going to be deterministic. Matt's going to be probabilistic. And let me, just so you all know, CRC's to the rescue. Let me get this all set up. So Maddie's in the background. I didn't mention this at the beginning. There's actually a spreadsheet that drives the budget, so the values actually update. So Maddie's going to be in the background updating that for me. So I got to do a couple things here on my side to get this in a good place. All right, let me hide this so it doesn't give anything away. All right, Jake, so here's your deterministic forecast. Our deterministic, 32 degrees. So just go ahead and throw it in chat, or if you want to say it, that's fine too. Are you salting or are you beet juicing? 32 degrees deterministic forecast. All right, Jake salting. Fabulous. Let me go to the next. All right, Matt, 90% chance of temperatures staying above 25 degrees. Matt, are you salting or beet juicing? All right, both of you salting. Observed temp, 33. Fabulous. Good answer. So Maddie's going to update your budget. Should be $500 less for each of you. I'm going to go ahead and update that. And there you go. 99.5 you each have less. All right, here we go. Next round. All right, Jake, 22 degrees. Salt or beet juice? All right, Jake's beet juice. Matt, 90% chance, temps below 25. Salt or beet? All right, beet juice, both of you. Observed temp, 22. Fabulous. Good forecast by us. Another $8,000 since you both decided to beet juice. So there goes $8,000 off both of your budgets. Let me update the stats here. There you go. So we are neck and neck, 91.5 remaining for each of you. All right, deterministic. Jake, 30 degrees, salt or beet juice? All right, Jake salting. Matt, 80% chance of temperatures above 25. Salt or beet juice? All right, they thought about it. They're both going salt. Survey says observed temp 30 degrees. So salt was the correct answer there. Go ahead and update. That should be minus 500 for each of you. And we are still neck and neck. All right, here we go. It's going to get harder. Uh-oh. Jake, 25 degrees. Salt or beet juice? All right, Jake's beet juice. Matt, 70% chance of temperatures staying above 25. Salt or beet juice? Nope. That's going to be the next version of the game. All right. Uh-oh. We've got a difference. Matt salting, Jacob's beet juicing. Very good. Survey says 26. Matt with the W there. So Matt saved some money for himself based on probabilistic. So let's go ahead and update. You'll see Jake now 83,000 since he decided to beet juice, and Matt down to 95. So, oh, I see you, Jake. No worries. All right, next round. Here we go. All right, deterministic, 22 degrees. Salt or beet juice, Jake? All right, beet juice for them. Matt, 60% chance of temps below 25. Salt or beet? All right, both beet juice. Observe 23. It's close. But both did the right one there, so we'll take 8,000 from each of you. All right, maybe do one more. We'll do 2 more rounds. So here's one. 27 degrees, Jake. Deterministic. That's a toughie. Salt or beet juice? All right, they're salting. I like it. Matt, 70% chance of temperature staying above 25. Salt or beet juice? Both salting. All right. Ooh, really trusting the weather service forecast there. All right, 26 degrees was the observed. So salt would have worked for both of you. Go ahead and update the scores. We'll go on. This will be the last round here. We've got deterministic with 74.5, probabilistic with 82. All right, last round, round 7. Here we go. 26 degrees, Jake. It's not how the game works, Jake. All right, they're salting. Oh, all right. Trying to make a comeback. I understand. 60% chance of temps below 25 degrees, Matt. Salt or beet juice? All right, they're beet juicing. Survey says 23. Got pretty cold. All right, so that definitely seals it for the probabilistic. So that's where it ends up. Deterministic 61 left, probabilistic 74,000 left. So hopefully you guys kind of get the game. Like I said, it's simple. We've done it several times here with partners. We did it at IAM with partners. And really, when you can get in a room, what we did, Greg had one team, I had another team, so we were rallying them up. We had candy to give out. It really does kind of get them into it. And at IAM, it was actually really fun. And I think that's some of the feedback that we got from that session was just how fun that some of the partners had. So with that, I just want to thank all of you. I know with everything going on, this probably wasn't easy to sit through with heads in other places. So we really appreciate you hopping on and participating with us. So we will open it up now to any questions, comments, thoughts you all had for us. And I will stop sharing my screen as well so we can see you all. So any questions or comments or thoughts?
Thanks, guys. This has been a fantastic presentation. And I think gives all of us a lot of perspective of how we might be able to communicate to our partners, as well as kind of a framework for our own understanding. So really appreciate that. One question I had as we were going through the exercise, did you ever frame this as cost loss for them? Because I just went through like a real quick calculation. And so your cost of taking precautionary action would be $8,000. Your cost incurred by not taking action would be $13,000 because you have to beat and then do the extra labor. So it makes sense to act if your probability is greater than 61%. So I didn't know if you ever framed it that way for them mathematically, or just kind of let them make the decision with the probabilities, because it seemed like Matt was pretty close to that in his decision making.
Sure, Matt was probably doing it, knowing him on the back of a paper too. But no, so we did not intentionally. This to me was just kind of an introductory. This is why you should at least consider probabilistic. I think when I do this again with similar groups, then I will introduce cost loss and say, have you ever thought about this? I think just my concern with doing cost loss was just too much thrown at them at once. I think the game itself is just enough to think through. But I totally agree. That's where I'm headed with this. But it was kind of that's the next step. But thanks for bringing that up. I totally agree with you.
Awesome. Thanks, guys. If you do have questions, feel free to raise your hand or type them in the chat box. I do see one from Kathy asking, what do we see in the future? We've been in the probabilistic world for a few years now. What will take our probabilistic messaging to the next level?
Yeah, I'll take that, and Maddie and Greg, feel free to chime in. So Kathy, we are, there is a team nationally as part of Ken's 10 working on probabilistic IDSS. And this game and a lot of other presentations and partner outreach stuff will be a part of what we're calling a partner outreach toolkit. The challenge that we're running into, in Central Region, we've been doing it probably longer than most, whereas some of the other regions, probabilistic is kind of new to them. So I think the first piece is kind of getting everyone at a baseline level, and then some of these national teams will start taking it to the next level. I know we're also waiting, and Jenny can speak to this as well, on NBM. That's going fully probabilistic as well. So I think that's going to be a massive a leap in undertaking into this probabilistic world as well. So I think there's a lot of things coming in the next year or two that will kind of push us that way more. But I hear you. I'm ready to keep going too. Maddie, I saw you pop on if you had additional comments.
Yeah, I was just going to throw in there, things that aren't really in our control right here if we're just working at a WFO or things like that. Like right? Our DESI color curves, that's been a topic of discussion for a while. There's a lot of work being done right now to collaborate and advance how we're presenting some of this data. So some of what I said, right, with you don't want the same shades of green for your pop if it's not pop. We need to separate that and make it visually distinct. There's a lot of conversation going on with all of the teams and everything to improve the way that we're presenting that way. So I'm hoping that the field will be able to see some of these changes here in the next, well, who knows exactly, but here in the near term. I think we're making some real progress now that we're getting some additional social science research out there that's specific to meteorology and our visualization that way, because we can pull a lot of things, and we do, from the medical field, similar other STEM fields and communication, but to see stuff that's directly applicable now is very helpful. So.
I'm just going to hop on. Nothing really big to add, but kind of what Jenny was alluding to with the cost loss. I think that's going to be a crucial thing going forward, stepwise, to really make the partners. I think a lot of them do think probabilistically now. A lot of them have an understanding now, since we've been doing it for a long time. Like you said, Kathy, in such a region. But the fact that we can now quantify it to a certain extent, like if you don't take action based off of information we're telling you, this could be a much bigger and more severe or significant issue for you down the road, kind of deal. So I think the cost loss is going to be a huge part going forward when it comes to probabilistic messaging in general, tying that in together.
Great, thanks, guys. Do we have any other questions? All right, I am not seeing any. Thanks again for presenting today. This has been awesome and a great example of kind of what we're looking for with our future innovation spotlights, not only the interaction, but just getting everyone excited about things that are coming for us. So really appreciate that again. If you do have any further questions, I'm sure our authors today would be willing to have you reach out to them. So thanks again, everyone.
Thanks, Jenny.
Yeah, everyone stay warm. Right on.
Thanks.